So this unit is on quadrilaterals, which are shapes that have 4 sides. We have a particular type of parallelogram, or a specific type of quadrilateral that's called a parallelogram. That is where opposite sides are parallel. So that's the first property. Opposite sides are parallel. Thus, the name. Well, it has other properties too, such as the sides that are opposite each other. They look like it, but they are actually the same size. So these two are the same. These two are the same. These two are congruent. These two are congruent. These have the same length. These have the same length. So opposite sides are congruent. What else do we know? I'll stick with the green. We know that the opposite angles are congruent. So if you look, these two big angles that are across from each other are the same degree or the same angle measure. These two are the same. So opposite angles are congruent. Well, there's more properties also about the angles. We have 2 for the sides, 2 for the angles. Opposite angles are congruent. What about the ones that are next to each other? Well, these, which we call consecutive angles, they are supplementary, aka they add to 180. What else do we know? Well, we know 2 things about the sides, 2 things about the angles. The last one is the diagonals. Diagonals are if we connect these opposite angles together. What do we know about them? Well, this one, when it comes across, cuts this in half. When this one comes across, it cuts this one in half. So what happens here? Diagonals bisect each other. Diagonals bisect each other. 5 properties of a parallelogram. Next, rectangle. So the reason why we have this line here that breaks into 2 is we have quadrilaterals, and a special type of quadrilaterals are parallelograms. These are ones where the opposite sides are parallel, and you get all these other properties. Well, sometimes you have parallelograms that have all the same angles. So all 4 of these angles are the same. So all angles are congruent. And we know that these are 90-degree angles. But all the angles are congruent. What if you have a parallelogram where not all the angles are congruent, but all the sides are congruent? Well, that is a rhombus. These sides are all the same. All sides are congruent. All right, let's go back to rectangle. These are all 90 degrees. They're all the same though. Here, all the sides are the same. So rectangle to finish it off, what else do we know? Well, we have these diagonals. This is used a lot in construction. The diagonals of a rectangle are congruent. Diagonals are congruent. In other words, you can measure across from the angle of something, like say a table across and a table across. If they're exactly the same, then you know that these are not right angles because it's a rectangle. All right, let's see. Now rhombus, all sides are congruent. What do we know about this one? The diagonals Well, not the same size, because that one's short, that one's a little bit longer, but they do cross at a perfect 90-degree angle. So here, diagonals are perpendicular. AKA 90 degrees. This one has a third one, but the diagonals bisect opposite angles. What does that mean? These diagonals cut this one, this one, this one, and this one, and make sure they're all the same. Then this long one comes across and makes these small ones all the same. So rectangle has 2, rhombus has 3. What happens if a rectangle and a rhombus are merged together, aka all the angles are the same and all the sides are the same? That's where you get this square. And a square has all the properties of everything above it. A rectangle has the properties of this and all the way above it, but not these. A rhombus has all these properties, but not these. And a rhombus also has all the properties above it. A square has all the properties of a rectangle, a rhombus, and a parallelogram. The only thing new that it brings to the table is when the diagonals bisect, or the diagonals cross, they bisect every single one of these the same. So diagonals bisect not just the opposite angles, but all angles. And they end up equaling 45 degrees. Because all these are 90, bisected means every single one of these 8 are 45 degrees. So there's our properties. We went through memorizing them, and then we started to use them and see if they are correct in different situations. So here are some. We're asking ourselves, are all quadrilaterals a rhombus or a rhombi? Well, a quadrilateral could be a parallelogram, so it doesn't have to be a rhombus. A quadrilateral could be a rectangle. It could be a rhombus. But are all? Not all. Some are, but not all. No. Are all quadrilaterals a rectangle? Same idea. Quadrilaterals could be a rectangle, but it could be something else. So no, not all. Are all quadrilaterals a parallelogram? No, same idea. Quadrilateral could have no sides that are parallel. It could have none of these properties. It could be something funky, like there. Let's make a long side. And let's make a weird one coming inside and going out. That's a quadrilateral. It has 4 sides, but is not definitely not have these properties. All right, are all squares a rhombus? A square has all the properties of everything above it. So a square is always something that's above it on this graph or this organizer. So a square is a rhombus, a square is a rectangle, a square is a parallelogram, a square is a quadrilateral. So a square, are all squares a rhombi? Yes. In fact, that's true of all the squares. Are all squares a quadrilateral? Yes. So you can do that with all the squares. Are all parallelograms a quadrilateral? Yes. Anything here is always the thing above it. So a square is always something above it. A rectangle is always a parallelogram and always a quadrilateral, not sideways, not downward, but above it. So rhombus, not a rectangle, but it is a parallelogram and it is a quadrilateral. It might be a rectangle, it might be a square, but not always. Are all rhombi a parallelogram? Is it above it? Yep, rhombus is a type of parallelogram. Are all quadrilaterals a square? Nope, that's going the wrong direction. So quadrilateral could be one of these, but not always. Are all parallelograms a rectangle? Nope, sometimes. Are all parallelograms a rhombi? No, sometimes. Are all rhombi a quadrilateral? Yes, it always is something above it, and so a rhombus always has four sides. So this means that all these that we've answered and about to answer, they have all the properties above it. So a square has all of these properties. A rectangle has all of these properties too. A rhombus, not these, but has all these properties, four sides. All right. Are all parallelograms a quadrilateral? Nope. Sometimes. Are all rectangles a quadrilateral? Yep, it has four sides. So yes. So there's your front side. If you remember these properties, then you should be able to solve these. And then in most cases, I allowed cheat sheets, so you had some of this. But there we go, test review, page 1. Now let's flip it and go to page 2. All right. All right, let's do the sides first. HG. HG is this side right here. That is the same to the one across from it. Okay, how do I know that? Well, I'm told it's a parallelogram, and for parallelogram, opposite sides are congruent. All right, how about EH? EH is the same as the thing across from it. So that's 14. I forgot to write the first one, HG. That's 13. Okay. This part can get a little confusing, so I'm going to use a post-it. E, F, G, H. So this line, this arc right here tells you that the whole thing is 130. 58 doesn't have that arc. So that is telling you that this angle in here, this one, is 58. Has nothing to do with this part. All right. So angle HEF. HEF is this big one. HEF, this one. Well, we know from quadrilaterals, from parallelograms, that opposite angles are congruent. So across from that one is this one. So that's 130 degrees. So HEF is 130 degrees. The measure of EG. EGH. Ooh, that's over here. I'm going to skip that one. I'll skip that one for a second. HEG. Skip it. EHG. Okay, let's do EHG. Okay, so EHG. Doing that one because it's simpler. EHG is this one right here. So what do I know about that one? Well, if I look at my properties of parallelograms, the angles that are next to each other are supplementary, which means they add to 90. So if this is 130, you add it to that one, it should equal 180. So if I subtract 130 from 180, 50 degrees, this should be 50 degrees. And getting ahead of myself, the one across from it should be 50 degrees. So EHG is 50 degrees. EFG is also 50 degrees. All right. Now I can focus on these other ones. All right. EGH. EGH I could draw that better. GH, E, F, G, H. So how do I figure out what EGH is? See if I can find a Sharpie. I guess not. EGH. Whoa. That's a trash pen. Oh, there's a Sharpie. Okay. EGH. EGH. What do I know about this angle right here? Well, it's not a part of the parallelogram. It's dealing with this diagonal through the inside. So what do I know about it? Well, going back to a unit on transversals way back in the day, when you have two parallel lines cut by a transversal, we have all these relationships between the angles. And this is a parallelogram, so we know that this is parallel to this. So this line right here is our transversal with that. So this cuts through those. And what are some of the relationships? We know that angles in here and the other one on the inside are the same. So I believe I know one of them. Nope, that's not helpful. Oh yeah, it is. Yeah, so I know EGH because I know FEG. So this is 58 degrees. So this other one over here needs to be 58 degrees. All right. Now I'm going to keep this here for a second. And from before, as I see, I have HEG. Is this angle up here? This one. If I cover it up, that part's 58. I want to find that part. What's the whole part? Whole part is 130. So the whole part is 130 minus that 58. And what's left is that piece over there. So there's my 2, there's my 1, gives me 2, gives me 8. So that's 82 degrees. 82 degrees. And EGF over here, we're doing a very similar transversal situation. This one and this one are parallel, cut by this transversal. So this right here is the same as right there. So that's 82 degrees also. That's easily the trickiest one because of all the lines that cross each other. Your best bet is to try and visualize just the quadrilateral and ignore the insides, solve those problems, and then come back and you're dealing with these transversals and you're looking for anything that looks like a Z, an S, an N, or a weird N. If you can find those, the angles in here are going to be the same if it's a parallelogram, because those are transversal properties. All right, trash them. All right, so now we're dealing with this rhombus over here. We have properties of a rhombus and everything above it. All right, so let's see what we got. First, let's deal with sides. All right, if that's 37, that's 37, that's 37, that's 37. All right, so I'm asking for KO. Yep, KO. 37. OL is 37. MN. Nope. KL. Nope. Okay, so what else is going on with these? Well, for a rhombus, these bisect each other. So this part and that part right there are going to be the same. So if this is 25, this part's 25. And I'm not asking for Km, I'm asking for KL. So KL is 25 plus 25 gives me 50. The whole distance across. And then Mn is just this distance right here. What do I know about this part? That should be the same as that part. So that's 16. This is 16. So it's 16. All right, let's see what I got. LKN, LKN. So I'm looking at this angle right here. Before I even look at numbers, that's the same as this one and the two across from it. Okay, I know that's 18. So that's 18, that's 18, that's 18. So this is 18 degrees. KMO, KMO. Ooh. For rhombus, the diagonals are perpendicular, aka 90 degrees. So KMO, KMO is right there in the middle. That's always 90 degrees because those are perpendicular. So that's 90 degrees. All right, how else am I trying to trick you here? NOL, NOL. Ooh, that is a little sneaky. This one right here. NOL. How do I figure out that one? That's the trickiest one of them all. This triangle has one angle that's 18 degrees. The one in the middle is 90. We don't know the other one. But what else do we know about triangles? All three angles should add up to 180 degrees. So if we subtract those, we'll know that last piece. So let's see, 180 minus 90 is 90. 90 minus 18 is 72 degrees. So that right there is 72 degrees. All right, what's left? OKN, OKN. Remind myself, this is 18, so this is 18, so this is 18. So OKN is a combination of both of those. So that's just 18 plus 18. So that's 36 degrees. These are very standard questions for this unit. A parallelogram with the diagonals crossed, you're going to find random sides and random angles. Same thing with the rhombus. So using these properties, put some numbers and some angles. How to make it tougher? We start throwing some algebra into it. So let's get into that. All right, number 3, solve for W. Solve for W. Ooh, I got 2 W's. So what do I do? Well, it's a parallelogram. Parallelogram, opposite sides are parallel, not helpful. Opposite sides are congruent. Ooh, that's helpful. So the opposite sides are congruent. That means this one and this one are the same. It doesn't say anything about connecting to this one, but these two are the same. And if those are congruent or the same, that means I can write them equal to each other. And if I can write them equal to each other, now I can solve that using a little algebra. So W equals 5. So I found W. Check. Move on with my life. If you're watching this, you now know the secret tricky one is if I ask you to find out what BC is. BC is 5W. Now you know W. So 5 times W, or 5 times 5, is 25. Yes, that's on the test for sure. It's only worth like a point, but a lot of people missed it. Now hopefully you won't. Number 5. Here we've got a rhombus. How do I know that? It's got 4 equal sides. All sides are congruent, so it's a rhombus. So these are all the same. So here's your algebra. That equals that. So 4x minus 24 equals 100. This is definitely more algebra than geometry at this point. I'm going to add 24 to both sides. This cancels out. Bring down that 4x equals, that's 124. Got to get the x by itself. So 4 times x. What's the opposite times? Divide. So divide both sides by 4. I get x equals 4 goes in there. What? 3 times 1 time. 31. X equals 31. Ooh. Alright. How do I make it trickier? This is a good one. Got all this information. You need to know how they relate or how they don't. Kind of happen above here. So what do I know? I know that for a rectangle, all the angles are 90 degrees or congruent. This has nothing to do with angles. Diagonals are congruent. Nothing to do with diagonals. A rectangle is also a parallelogram, so it has all these properties. Opposite sides are congruent. So that's what we need. This is equal to this. So 4y plus 8 equals 40, because those are the same. So I'm going to subtract 8 from both sides. 4y equals 32. Divide by 4 on both sides. I got y equals 8. Pretty straightforward. The next one, now this side and this side are the same. So I can write them equal to each other. And I can tell this one's a little trickier. It just has one more step of algebra. All right, so I need to get the z's on one side. So I'm going to subtract 5z from this side and this side. So that cancels. I'm going to move the 28 over. So positive 28, so minus 28. I have to do on this side too, minus 28. So that cancels. What am I left with? 3 minus 5z. That's negative 2z equals, that's gone, that was gone. Negative 14 minus 28 is negative 42. To get the z by itself, I'm going to divide by negative 2. And z equals negative, cancels out with a negative. That goes in 21 times. And there you have it. More or less, that's going to be what your test looks like. Maybe some of the shapes are a little different. The algebra is definitely going to be different. But shouldn't be any surprises. This should easily get you a very good grade. All right, good luck. Get to it.